So hi everyone, today we'll be discussing about what is standard scaler or the z-score normalization. So basically, it is one of the most prominent methods for scaling any numerical feature. And the best part about standard scaler and z-score normalization is that it can also help us to capture out outliers in the dataset given. So let's understand the formula first. So the formula is pretty easy. It means like x minus the mean of the total numerical feature divided by the standard deviation of the feature. Now a few key points about standard scaling is that it is unbounded. That means that it doesn't have very particular range in which the values would dwell after scaling. So like for example, in case of min max scalar we have a range 0 to 1. In other scales we have a range from minus 1 to 1. But in case of z score normalization, we don't have any particular range and the values can range are unbounded. So there is no particular range in which the values would be limiting. uh, if the value that are the final value that are scaled are beyond minus 3 or 3 is out of the is out of this particular range, then it is possible that the value can be a potential outlier. The new scale data has a mean equals to 0 and variance equals to 1, and it works better with normally distributed data sets. So let's see a practical example how standard scaling works over a given data frame. So here, what we have done is that we have declared a dummy data frame where ABC have are all normally distributed with different means. So A has a mean equals to 0, B has a mean equals to 100, and C has a mean equals to 1000, with standard deviation equals to 1. Now, using the scale and preprocessing package, we have imported a standard scaler, and we have fit transformed the whole data frame passing to the standard scaler. So these all these functions works on these columns separately and not combined. So don't get confused with that. Once we have got an output, the output that we get scaled underscore df is a numpy array. So we need to convert this back into a data frame. Now eventually when we visualize this data frame, you can see that how the values have got scaled. So for column B and C, you can see that the range is from minus 3 to 3. It's pretty visible. But in case of column A, because of the presence of the outlier, the outlier has got a value of 30, while the rest of the values, if I remove that particular outlier, can see the values are lying from minus 3 to 3. So as I told you earlier that standard scaling can help us in determining outliers also, as as the value for outlier has passed 3 or minus 3. Eventually it is also helping us to determine outliers as well, and while the rest of the values are uniformly scattered throughout the given range. So yeah.